Right. Is this working? Yeah. Okay. So instead of a piece of theory here, we're going to go with a piece of engineering. And I'll hopefully along the way explain what the title is all about. So observation, if you look at a lot of OO languages, certainly they're conceptually very similar, otherwise we wouldn't actually put the same label to them. And a lot of them are actually syntactically fairly similar. A way you can think about it is if you look in linguistics at all the Romance languages, if you know a couple of them, like say French and Spanish, then Portuguese is not that bad. And you can kind of read them. They're not that different. And similarly, if you've learned 2 or 3 somewhat different languages, you can pick up another, you can actually read them, and you won't be fazed by almost all of it. So maybe, and even more importantly, the things we tend to say in those pieces of code tend to be very similar. And that's a really key observation. The things you say in an O language is very different than the things you say in Prolog. So that's a source of commonality that one might be able to do something with. So can we do it? And then the question is not, can we create the one language to rule them all in the sense of abstracting out the language, but can we create a language where OO programs that people tend to write can be written once and for all? So we kind of want to use our DSL sauce to have a DSL for OO programs, not for OO programming languages. And you know, pick some languages. Now, if those of you who know me, like I despise OO. I hate the stuff with a passion. Like if I slum it, I use Haskell. So this is kind of a weird thing for me to do. But sometimes you want users. So pick some mainstream languages to be abstract over, to have the most users. Now, here's something really different that we tried to do. The programs that we're going to be generating, because this is PEPM, so we generate programs. Generating programs that computers can understand is easy. Old hat, everybody here knows how to do that. You know, we do it in our sleep. Generating programs that humans can read, that's different, right? With all that GenSim stuff and lots of things, and generating programs that are one big line long and unreadable. Can we do that too? In fact, not only are they readable, if I'm going to generate a piece of Python code, a Python programmer should go, yes, this is Python. It's very easy to write Fortran in Python. It's very easy to write Fortran in almost every language, and it looks like it. It feels like it. It's hideous. You don't want to read it. So if I'm going to write Python, I want to write Python. If I'm going to write C++, I'm going to write C++, and so on. The bar is a little higher. And, well, may as well write documentation since we've gone this far. Why not? The OO people have silly languages, and so there's things you can't say in OO. You have to go meta and have design patterns, right? Okay, fine. Well, if we're going to be going meta, we may as well make those design patterns code idioms in our meta language. Because that's what they're going to say anyways. And it has to work in real examples. Otherwise, you know, this is just amusing. So these are our requirements. This is what we want to do. Right. Oop, forgot one. And there's some common idioms further than the patterns that we kind of want to abstract out as well, to reduce code duplication and the generated stuff. Okay, so how do we do this? What's our approach? It's a very, very much a reverse engineering approach. Take a piece of code that exists and figure out, what's the actual content and figure out how to write that once and for all. By doing this, one of the things we can do is, okay, so our target languages are C++, Java, Python, whatever. One of the ways to start is to actually have a human being write an application 4 times in each of the languages in idiomatic ways and go, all right, that's our target. How do we get there? That was our process. And one of the key parts here to remark once you're starting to look at this is in a lot of languages, there's a bunch of stuff you can say. So in C++, you can say weird stuff via templates, but you can't say that in Java. Now within Java, you can do weird stuff at introspection, which you can't do in the others. Yes, you can say that, but we don't really care. Like in some sense, you can, but do you really want to? For a bunch of languages, it's not necessary. And then you shift over to, well, okay, to get my programs to run, there are things that I want to say. I want to say them because that's part of my knowledge base that I want to teach the computer. And then there's the weird stuff that you need to say to make actual programs that actually run. And so if you're in C, you need to say all sorts of stuff about memory management. And if you're in other languages, you don't need to say that. So there is things that you need to figure out about, what do you actually need to say? And of course, you want to concentrate on the stuff that you want to say, because as a human being, that is necessary. Okay, for example, and readability features. So if you look at the code below, which is almost in any language you'd possibly want, it's 2 blocks of code with a line of comment. This is how people write code. And the reason they're in blocks is they're somehow related to the author, like those lines of code. But a block semantically means nothing. Nevertheless, if our output is going to be human-like code, we need the concept of a block in our, whether it's AST or whichever way you want. This is an important concept because it has communication concepts. So we need to add more stuff to our language to be able to deal with the issue of how people actually write their programs. And then there's other stuff that comes up. And we see this, for example, very well in OCaml when you have references. Naming the variable and naming its value are 2 different utterances. In most procedural and OO languages, use mention or collapsed into one thing, you kind of have to separate them out in general. Even if at the end of the day, none of the languages that you generate actually worry about this, your code generator still has to, because of making sure that you have the right information at the right time in the right place. So this matters. And then of course, you don't want your AST to be too big, but if you program in too raw a language, it's tedious, so you start using a whole bunch of smart constructors to make it nicer. That's just, and then there's more, but yeah, these are the 2 interesting ones. So here's sort of the language. It's big, all the way down to dealing with stuff with packages. You're not really meant to read this. This is just an impression. It's not like an AST with 12 things in it. There's a lot of stuff. Again, you will be completely unsurprised that I use the finely tagless approach to encode stuff. But here we need to do more. We really do need to use type families in Haskell. So yeah, we're doing something weird. We're encoding O languages and as a DSL in Haskell, but why not? Haskell is one of the best languages to encode other languages in. It's not the only one, but So we're abstract over our target language, and we're abstract over the language-specific representation of the data that we're interested in. So variables in different languages carry a different payload at code generation time, because each language requires different things being said, and so we need to kind of track that so that we can generate the code properly. And so that each of the instances of a variable symbol will be somewhat different because the representation type of a variable is different, and it allows us to play around with that. So here's, and some people think that finally tagless is not modular. So here's the 42 classes that make up our stuff, and since this is entirely unreadable, if I take the graph and split it in two pieces, it's a slightly more readable and perhaps not even. You know, types are at the bottom and packages are at the top, and it's otherwise you would be, if you were actually able to read this, you would be completely unsurprised. Yes, this feels like a programming language. This is the set of syntactic categories of a programming language. There is nothing weird. So that's kind of comforting that you know, it looks right. So 43 classes that encapsulate 328 methods. You know, languages are big. The interesting part is things like this column. So if you haven't looked at some languages enough, you may not know this yet. Java and C# are essentially the same language. Like you can barely tell them apart. And this is kind of more formal. Like our code generator for both of them is essentially one code generator. There is a handful of routines that are different, and that's it. They're the same language. On the other hand, Python and C++ do seem to be somewhat different. You know, they are more different than other languages. But there's still, you know, 150 or so odd pieces of code that are identical for generating stuff. So they're not that different at some level. Things we want to say, need to say, just a bunch of stuff. In most languages, you don't have nice routines for doing lists. They're all done in libraries, and so your list code looks kind of ugly. So it'd be kind of nice to not. And so, well, since we're creating our own language, why don't we make some list routines that look kind of nice? And then if the target language allows that, then it looks nice. If the target language doesn't, well, you generate ugly code because it's an ugly language. And so on for other stuff. All the way up to design patterns. And it makes it more convenient. All right. We don't have an external syntax for GOOL because we're still experimenting, and therefore it's embedded in Haskell, and therefore it looks absolutely awful and hideous, we know. So this is not meant to be pretty. But it does generate a nice piece of Python code for a slice. You know, old is from 1 to 3 and step by 1. But, you know, if you're doing the same thing in Java, you kind of have to write something kind of ugly to do exactly the same thing. But this one line of GOOL means both of these things, or in C# or in C++. And if you want to, you know, do a pattern and create a set method, then it's a very short one-liner. You kind of have 3 pieces of information that you must say. It's a set method. What's its name, and what's the name of the variable? And there's 3 pieces of information there, no more. And it generates the Python, the Java, the C#, and the C++. All right. So this is part of a bigger program project called Brazil that out there. it's with documentation. Basically, it's generating everything. And the focus on Brazil is actually on generating documentation, not generating code. GOOL is the back end. We're spend a lot of time in our case studies. So there's a piece of code that I linked to. Let's say, I don't know, Python. This is actually generated, come on. All right, we're just slow. If this ever came up, I would be able to show you a piece of HTML that's generated at the specification for a projectile calculation program, and then we generate code for that. And the code is actually relatively short, and of course, rely on the internet and you fail. The code is relatively short, and the interesting part is the specification is longer because the mathematics behind projectile computations is non-trivial. And so the content of the code can look relatively small, even though the explanation for why it's correct is bigger. Yeah, except that I've got so little time, I'm actually going to finish my slides. Anyways, one of the interesting stuff is that we have knobs. We can turn a documentation on and off. We can turn how the inputs look on and off, whether they're bundled and unbundled and via classes, via this, via that. Do you want a whole lot of logging? So like the old aspect-oriented stuff. If you're actually generative instead of doing aspect weaving, this is easy. You can generate an entirely modular piece of code, or you can generate a big ball of mud. It doesn't matter. And the big ball of mud can run really, really fast, but is not so friendly for humans. Yeah, twiddle the knobs until you're happy with what generates. We're doing a whole bunch more stuff on this. And the current really exciting work is that we're really trying to focus on what you really need to say, and what we really want to say is, what's the design of this code? And that is the programming language we're most interested in is the programming language where you're not writing programs, but you're writing design decisions. And then writing the program is the easy part. Making the design decision and writing them down in a proper language, that's the interesting part. And then GOOL is just our way of getting that done. So it works. Now I'm done.
Right, there's time for questions.
Satnam has a question.
So it seems like you're kind of forced. It seems like you're forced to adopt the lowest common denominator of 4 languages. So the setter that you had, for C++ generated code, there was no visibility information, right? Whether something's
yeah, actually, we have that. We do allow you to set the visibility if you want.
Does a sensible LCD exist so that you can write reasonable programs, or you'll be eventually be forced to make your system more and more complicated to accommodate realistic programs?
Yeah, so the best answer is I don't know yet, because our examples are medium small programs that are mostly all scientific computation, which is mostly where we care right now, because in the kinds of programs we're really interested in writing, we're interested in certification. And so human beings really do want to read the code and know that, like, we're really focusing on traceability one level up. So I don't know.
It's time for more questions. Yeah.
So you mentioned that you had some knobs to turn for, well, depending on what you want.
Yes.
So do you do some kind of static analysis on the GOOL code to, let's say, suggest which backend to use? No. It's all, like, we very much believe that design is a human activity. And so the knobs are all a person
turns them. And if they choose something dumb, that's their problem.
Right. Okay. Thank you.
Okay.
I might be able to find an example, but
So, final question.
Do you know what is the categorical semantics of object-oriented programming languages?
well, other people have essentially said like tons of stuff with coalgebras, but in some sense, this is irrelevant to the particular case here because this is pure semantics by translation. So it's kind of a operational semantics kind of approach. But yes, in other talks I'd be interested, but not here.
Okay, let's thank Jacques again.